Hello everyone, I hope all of you are safe. In this video we'll talk about section 2, which is radioactive decay. So we have a question: what is a radioactive decay? Radioactive decay is the spontaneous disintegration of a nucleus into a slightly lighter nucleus, accompanied by emission of particles, electromagnetic radiation, or both. As we said before in section 1, we have some unstable nuclei or nucleoids, as we said in the nuclear chemistry. These nuclei need to be more stable, so it needs to return to the more stable nuclei it can reach to it. So the radioactive decay occurs due to this. Nuclear radiation is the particles or electromagnetic radiation emitted from the nucleus during radioactive decay. And as we said, an unstable nucleus that undergoes radioactive decay is a radioactive nuclide. All of the nuclides beyond the atomic number 83 are unstable and thus are radioactive. As we said before in section 1, according to the band of stability and the proton and neutron ratio. Now we will talk about the types of radioactive decay. A nuclide's type and rate of decay depend on the nucleon content and the energy level of the nucleus. So it's not dependent on any other factor except those two factors, the content and the energy level of the nucleus. The first one is alpha emission. An alpha particle is two protons and two neutrons bound together and is emitted from the nucleus during some kinds of radioactive decay. So it have the symbol of the helium atom He4 here, representing the mass number, and 2 here are the atomic number. The alpha particle have a charge of +2. Alpha emission is restricted almost entirely to the very heavy nuclei. And for example, here the polonium, which turns to the lead and releasing the helium atom here, or the alpha particle. Yes, okay, let's have a look more deeply and let's focus on the atomic and mass number change. Here we will find that the atomic number, which is 84, become 82, and the mass number, which is 210, become 206. So it loses 4 and 2. The second one is a beta emission or a beta particle. It is an electron emitted from the nucleus during some kinds of radioactive decay. It have a charge of -1. It decreases the number of neutrons. How? A neutron converted into a proton and an electron. Add this equation. Here the atomic number, here the mass number is 1 and the atomic number is 0. It become 1 the same, and the 0 converted to 1, so the atomic number increases by 1 and the mass number stay the same here, if you notice. And the beta particle emitted from this in this radioactive decay. Here example is a carbon atom which have a 14 mass number and 6 atomic number. It turns to nitrogen which have 14 mass number and 7 as an atomic number, plus releasing a beta particle. The third one is a positron. A positron is a particle that has the same mass as an electron, but it has a positive 1 charge, and it is emitted from the nucleus during some kinds of a radioactive decay. It happened to decrease the number of protons. How? The proton can be converted into a neutron. It's unlike the beta particle where the neutron turned or converted into a proton. Here it happened the opposite of this. Let's see the equation. Here the elements we have, the radioactive element we have, it turns to another radioactive element but with a decrease in the atomic number, but the mass number stays the same. So what this element lose, this particle gain, which is a positron, so it have a positron, it's have a positive charge. It's unlike the beta particle which have a negative charge. This is an example. K 38 and 19 turns to argon which have a 38 and 18 and releasing a positron. So as we said and as we noticed, the atomic number decreases by 1 and the mass number stays the same. The atomic number and the mass number stay the same. Another type of decay is the electron capture. In electron capture, an inner orbital electron is captured by the nucleus of its own atom. It's non-natural to the electrons to be inside the nucleus, but in this type of decay, the electron captured inside the nucleus. To increase the number of neutrons, an inner orbital electron are combined with a proton to form another neutron. So it will increase or decrease the atomic number and the mass number. It decrease the atomic number and the mass number stays the same. So here the mass number stays the same but the atomic number decreased by 1. So it's somehow like the beta particle. Okay, here an example: Ag 10647 plus electron, it become Pd 106. The mass number stays the same but the atomic number decreased by 1 from 47 to 46. And the last type of decay, here it's not a particle, it's radiation. It's the gamma rays. The gamma rays lays here in the wavelengths of the electromagnetic waves. Here like the visible light, here it before the visible light. The gamma rays are a high-energy electromagnetic waves emitted from a nucleus as it changes from an excited state to a ground energy state, like what happens when the electron moves and the light, we have seen the visible light, is produced. So now we finished the types of radioactive decay. Let's move to have some questions to check that we have a good understanding for this part. Our worksheet, we will solve from the page number 1. Okay, this worksheet labeled by section 2, radioactive decay. We will deal with the first 4 questions and the multiple choice questions. In the space provided, write the letter of the term or phrase that the best complete each statement or best answer each question. Number 1. The process N10 produce or yields P11 plus P0 negative 1. Represent A or an alpha decay, beta decay, electron capture, or fusion. Take care of the charge here of this particle. The charge of this particle here that I'm pointing to. Yes, it's a negative charge, so it's a beta decay. The answer is B, beta decay. So let's move to the next one, to the nuclear reaction. Na2111 yields Ne2110 plus PO positive 1, occur through the process of annihilation, positron emission, electron capture, fission. The positive charge here, the positive charge, so yes, the answer is B, it's a positron emission. 3. The atomic number of a nuclide that undergoes alpha decay increases by 2, increases by 4, decreases by 2, decreases by 4. Alpha decay, alpha decay. It has a 4 and 2, so the nuclide loses or decreases, yes, by 2 and 4. Here he asking about the atomic number, or the question is about the atomic number. So the atomic number is decreased by 2. So the answer is C, decreases by 2. Now with the last question in this video, 3 forms of nuclear radiation ranked from most massive to least massive are alpha, beta and gamma, beta, gamma and alpha, alpha, gamma and beta, gamma, beta and alpha. It will be, let's check on the presentation. The alpha has a mass of, the beta has a mass of, positron has a mass of, and gamma has a mass of. So let's get back to the question. It's alpha, then beta, then gamma. So the answer is A, alpha, beta and gamma. Thank you for watching, and I will see you to complete this section in the next video. Thank you.